Fine. Let's start. Number 10. The Perytons. Imagine you're sitting inside one of the biggest radio dishes on the planet, the Parkes Telescope, in the middle of rural Australia. A 64-meter ear pointed straight up at the sky, listening for the faintest whispers from the far side of the universe. And every so often, over the years, it hears something. A short, sharp burst of radio energy, a few milliseconds long, smeared out across a range of frequencies in a way that, at first glance, looks exactly like it came from billions of light years away. They called these bursts perytons, named after a mythical creature that casts the shadow of a person instead of its own, which, honestly, turned out to be the most accurate name in the history of astronomy, because for about 17 years, these things haunted the telescope. They looked cosmic. They had the fingerprint of something deep and ancient and far away. And they were quietly wrecking one of the most exciting hunts in modern science, the search for fast radio bursts, because nobody could tell the real signals from the fakes. Here's what makes it beautiful. In the week beginning, January 19th, 2015, 3 fresh perytons showed up, and a researcher named Emily Petroff and her team finally had the monitoring equipment to catch something everyone had missed. Every single peryton at 1400 megahertz came with a little companion signal at 2400 megahertz. And if you know anything about kitchen appliances, that number should make you smile. 2400 megahertz is the frequency of a microwave oven. The perytons were coming from the observatory's own break room. But here's the thing. It wasn't just any use of the microwave. You could run the microwave all day and get nothing. The bursts only appeared when someone, standing in the kitchen, got impatient. When they grabbed the door handle and yanked it open before the timer hit 0. That premature interruption, with the magnetron still spinning down, released a little chirp of radio energy. And if the giant dish happened to be pointed at just the right angle, it caught that chirp and dressed it up as a message from the cosmos. 17 years. One of the most sensitive instruments humanity has ever built. Fooled by hungry astronomers who couldn't wait for their lunch. Now, it would be easy to laugh this off and move on. And you should laugh. It's genuinely funny. People started calling it the cosmic microwave oven background, which is a physics joke so good it deserves an award. But sit with the uncomfortable part for a second. This was the best telescope, staffed by brilliant people, and for the better part of 2 decades, they could not tell the difference between a snack and a supernova's distant cousin. The universe wasn't sending these. We were, and we didn't know. Every signal that comes after this one in our countdown, every strange pulse and impossible burst, has to be weighed against that lesson. Somewhere out there is real signal, and somewhere much, much closer, there's always a microwave. And for 17 years, nobody could hear the difference. Number 9. The sun-like star signal. On May 15th, 2015, a Russian radio telescope caught something and then did the strangest possible thing with it. It said nothing for over a year. The telescope was Raton 600 in the mountains of southern Russia, near the Georgian border, a sprawling ring of reflectors, unusual even by radio astronomy standards. And on that night in 2015, it recorded a strong spike of radio energy coming from a very specific, very interesting direction, a star called HD 164595, a star that is, in almost every way that matters, a twin of our own sun. Same rough size, same rough temperature, about 95 light years away. And we already knew it had at least one planet. The signal itself had a wavelength of 2.7 centimeters and an amplitude that, if you did the math on how much power a civilization would need to beam it across 95 light years, was genuinely eyebrow-raising. If it were aimed deliberately at us, you'd need a transmitter far beyond anything we've ever built. If it were broadcast in all directions at once, you'd need the energy output of a serious civilization. And the Russian team sat on it. This is the part that gets under my skin. They didn't announce it. They didn't publish it. The detection quietly existed in their records for more than a year, while the rest of the world had no idea. It only became public in late August of 2016 when an astronomer named Nick Sunsef got wind of a presentation that was scheduled for a SETI meeting that September, and the story detonated across the internet. Strong signal. Sun like star. Under investigation by SETI. For about 72 hours, a lot of people let themselves believe. And then it deflated, the way these things always do. Once the signal got proper scrutiny, the most likely explanation turned out to be depressingly local, terrestrial interference. Some accounts point to a passing military satellite, a piece of Soviet-era hardware wandering through the telescope's field of view. Russian astronomer Yulia Sotnikova confirmed the probable earthly origin, and the killer detail, the one that should have calmed everyone down from the start, was this: the signal never repeated. One spike, one night, then silence from a star that, if it were really trying to talk to us, had 95 years of runway to try again. But I keep coming back to that year of quiet. A detection strong enough to eventually make global headlines, held in a drawer, unspoken, while the star that maybe sent it hung in the sky exactly where it had always been. We almost never heard about it at all, and that's the thing about the signals we intercept. Some of them we're not even sure we were supposed to know existed. Number 8. The Sky Eye signals. There's a telescope in the mountains of southern China so big it doesn't sit on the landscape. It sits in it. Fast. The 500-meter aperture spherical telescope. They call it Sky Eye. It's a bowl of metal panels half a kilometer across, nestled into a natural sinkhole, with a receiver suspended above it on cables like a spider at the center of a web. It is the most sensitive single-dish radio telescope ever built. If there is a faint conversation happening in our corner of the galaxy, this is the machine most likely to overhear it. And a few years ago, it did overhear something. Several somethings. Across observations in 2019 and 2022, the FAST team, working with researchers from Beijing Normal University, the National Astronomical Observatory of China, and the SETI group at Berkeley, flagged a handful of narrowband radio signals. And that word, narrowband, matters more than anything else in this whole video, so let me explain why. Nature is messy. When a star or a cloud of gas or a black hole gives off radio waves, it smears them across a wide range of frequencies. Broadband. That's the natural fingerprint. But a signal squeezed into one razor-thin frequency, a single sharp tone, is different. As far as we know, nature doesn't really make those. Technology does. Your radio station does. Your phone does. So when a search for alien intelligence turns up a narrowband signal, it lights up every alarm in the building. That is exactly the shape a message is supposed to have. One of the candidates was a narrow signal at 1140.604 MHz, caught on June 29, 2021, coming from the direction of a known exoplanet system, Kepler 438. For a moment, it fit. It had the profile. It came from somewhere you'd actually want to point a telescope, a star with planets. And then the team did the responsible thing, which is also the deflating thing. They looked harder, and they concluded the signals were very likely human radio interference. Dan Wertheimer, a veteran of this field and a co-author on the work, put it bluntly. The narrowband signals, he said, are from radio interference, and not from extraterrestrials. Here's the part that should keep you up at night, and it's the quiet engine underneath this entire list. The profile of an artificial alien signal and the profile of our own noise, a satellite, a phone tower, a stray bit of electronics, are almost identical. That's the trap. We built a machine sensitive enough to hear a whisper from another world. And it turns out that same sensitivity makes it brilliant at hearing us. The better our ears get, the louder our own voice becomes in them. We may already be drowning out the very thing we're straining to hear. Number 7. The SETI at home signal. For a while there, the search for alien life was running on your grandmother's computer, and your neighbor's, and a guy in Nuremberg's, and it caught something that, more than 20 years later, nobody has ever fully explained. The project was called SETI at home, and it was one of the most charming ideas in the history of science. The Arecibo telescope in Puerto Rico was gathering oceans of radio data, far more than any lab could chew through. So the solution was to give it to everyone. You'd download a little screensaver, and when your computer was idle, instead of showing flying toasters, it would quietly crunch a tiny slice of the sky, hunting for anything that stood out. Millions of ordinary people, all over the planet, turned into a single distributed brain scanning the heavens. And in March of 2003, that brain flinched. A candidate signal surfaced. Its designation is a string of characters that no human should ever have to say out loud, so we'll leave it on the screen. It was first pulled out of the noise by 2 volunteers, Oliver Volker in Nuremberg, Germany, and Nate Collins in Wisconsin, and it was announced to the world in New Scientist on September 1st, 2004. It sat right around 1420 megahertz, and that number is not a coincidence. 1420 is the frequency of neutral hydrogen, the most common substance in the universe, and it sits inside a quiet band that theorists have long argued is the natural place 2 civilizations would think to meet on the dial. The water hole. If you wanted to be heard, that's where you'd call from. The signal was seen 3 times. About a minute of data, total. And then the weirdness started. Because it drifted. The frequency slid, fast, somewhere between 8 and 37 hertz every second. If that drift were caused by the Doppler effect, by a source riding on a spinning planet, you'd be looking at a world turning nearly 40 times faster than Earth. Strange, but not impossible. Except here's the contradiction that breaks your brain. Every single time they came back and found the signal again, it had reset. It was sitting right back at 1420, the original frequency, as if the drift had never happened. A signal that races away, and then, each time you look, is exactly where it started. That fits no clean story. It's not the tidy profile of a natural object. It's not the tidy profile of a beacon either. Most likely, and I want to be honest here, it's noise, a statistical ghost, an artifact, a coincidence dredged up from an ocean of data by millions of computers looking very hard for a pattern. SETI at home itself pushed back on the headlines, and no follow-up ever confirmed a thing. But it was never killed either. It just sits there, in the record. The one a swarm of strangers caught on their home computers, that drifts and resets and drifts and resets, and refuses to be either alien or nothing. The universe occasionally hands you a shrug. Number 6, the galactic burper. 26,000 light years from here, past the crowded lanes of stars, past the dust, at the dense beating center of our own galaxy, something switches on. It shines in radio for about 10 minutes. Then it switches off. Roughly an hour and a bit later, it does it again. And again. And after more than 20 years of watching, we still cannot tell you what it is. Its designation is GCRT-J 1745, but everybody just calls it the galactic burper. And I love that, because it perfectly captures the tone. This isn't a graceful, elegant mystery. It's a thing near the heart of the Milky Way that goes off like a hiccup. It was found by an astronomer named Scott Hyman and his colleagues, buried in observations from the Very Large Array, taken on the last day of September and the first day of October, 2002. When they pieced it together, the behavior was unlike anything in the catalog. Every roughly 77 minutes, This source would produce a pulse of radio energy about 1 Jansky strong, lasting around 10 minutes, and then go quiet. On for 10. Off for an hour. A slow, patient, mechanical rhythm coming from the most chaotic neighborhood in the galaxy. And when they ran the numbers on how bright it was and how fast it flickered, they hit something genuinely strange. The implied brightness, if the object is as far away as the galactic center, is so extreme that it can't be produced the ordinary way, by hot gas glowing. It has to be what physicists call a coherent emitter. Something organized. Something where the radio waves are marching in step. In nature, that usually means a very specific kind of object, like a pulsar. But nothing about the burper's rhythm fits a normal pulsar. So what is it? Here's the honest, slightly maddening answer. Nobody agrees. One paper argues it's a strange, slow nulling pulsar, a neutron star that keeps flickering out. Another says it might be a white dwarf pulsar, a much larger, slower stellar corpse doing a job we didn't think white dwarfs could do. Another proposes it's a pair of neutron stars locked in a tight, deadly orbit. Each idea explains part of it. None explains all of it. 20 years of some of the sharpest minds in radio astronomy, and the burper is still, functionally, a placeholder for the words we don't know. And I think that's worth sitting with. We tend to imagine that the deep mysteries are all far away, at the edge of the observable universe, in some exotic distant place. But this one is home. It's in our galaxy. It's a steady, repeating, artificial feeling pulse from the center of the very structure we live inside. It's been keeping time this whole while, and we still don't have a name for what's counting. Number 5. The transient that shouldn't exist. There is a rule about dead stars. It's a good rule. It's held up for decades. And in 2023, astronomers found an object that has been calmly, quietly breaking it since at least 1988. Let me set up the rule first, because you need it to feel how wrong this is. When a massive star dies and collapses into a neutron star, it can become a pulsar. A city-sized ball of neutron material, spinning fast, sometimes hundreds of times a second, firing beams of radio energy out into space. Every time the beam sweeps past Earth, we see a pulse. Tick, tick, tick. But pulsars slow down over time. They bleed away their energy. And there's a threshold, physicists call it the death line, where a pulsar has slowed so much that it simply can't generate radio emission anymore. It goes dark. That's the rule. Spin too slow, and the lighthouse shuts off. Now, meet GPMJ 1839. It pulses once every 22 minutes. Not 22 times a second. Once every 22 minutes. That is agonizingly, impossibly slow for this kind of object. It is so far past the death line that by everything we thought we understood, it should be completely silent. There should be no signal at all. And yet, every 22 minutes, like clockwork, it sends out a bright, structured, polarized pulse of radio energy. The discovery was led by Natasha Hurley Walker and her colleagues using the Murchison Wide Field Array in Australia and published in the journal Nature on July 19th, 2023. And when they realized what they had, they did the smart thing. They went digging through the archives, old data from other telescopes going back years. And this is the part that made my skin prickle. They found it in 1988. The Very Large Array had recorded it. The Giant Meter Wave Telescope had recorded it. For 35 years, this impossible object had been sending out its slow, patient pulse, and it was sitting in our data the entire time. We had already caught the signal, multiple times. We just never noticed, because nobody was looking for something that, according to the rules, could not be there. It hid in plain sight, inside our own hard drives, for over 3 decades. The leading explanations now are exotic. Maybe it's an ultra-long period magnetar, a neutron star with a monstrous magnetic field, doing something we've never seen. Maybe it's a strange kind of white dwarf. And to be clear, nobody serious thinks it's a transmission from anyone. It's a natural object. But it's a natural object that proves our confident, decades-old rulebook has a hole in it. Something can spin far too slowly to make a signal, and make a signal anyway. That's the vertigo of this one. It's not that we heard something we can't explain. It's that we'd been hearing it since 1988, filed it under nothing, and walked past it for a generation. Makes you wonder what else is already in the archive, pulsing quietly, waiting for someone to finally believe it's real. Number 4. The ghost particle. Every second of your life, about 100 trillion tiny particles pass straight through your body, through your skin, through your bones, through the chair you're sitting on, through the entire earth, and out the other side, without touching a single thing. They're called neutrinos. They are the most antisocial particles in the universe. They almost never interact with anything. Which is exactly why, when one of them actually stops and says something, you should listen very carefully. Because to catch a message like that, we had to do something insane. We built a detector out of a cubic kilometer of Antarctic ice. Deep under the South Pole, there's an observatory called IceCube. It isn't a building. It's the ice itself, threaded with strings of sensitive light detectors, sunk into boreholes over a mile deep, watching 1 billion tons of ancient, perfectly clear ice, waiting. Because on the incredibly rare occasion a neutrino does slam into an atom in that ice, it produces a tiny, ghostly flash of blue light, and from the pattern of that flash, you can reconstruct where the particle came from. On September 22nd, 2017, IceCube caught a monster. A single neutrino carrying an energy of about 290 tera-electron volts. That's a staggering amount of energy for one subatomic particle, far more than anything our own machines can produce. The detector automatically fired off an alert to telescopes around the world within about 1 minute of the impact. And when they all swung around to look at the patch of sky the neutrino had come from, they found something staring back. A blazar. Called TXS-0506. A supermassive black hole at the center of a distant galaxy, roughly 4 billion light-years away, with a jet of matter and energy pointed almost directly at Earth. And at the moment that neutrino arrived, that blazar was flaring, erupting, screaming across the electromagnetic spectrum. For the first time in history, we had traced a single, high-energy cosmic neutrino back to a specific source in the sky. And then, when they went back through the older IceCube data, they found something even better. The same spot in the sky had produced an excess of neutrinos back in 2014 and 2015, before anyone was watching for it. This was not a fluke. That black hole had been whispering to us in ghost particles for years. Now stay with why this matters, because it's bigger than one detection. For all of human history, we have known the universe through light. Every star, every galaxy, every discovery came to us riding on photons. This was different. This was a message carried by matter itself, by a particle so shy it can cross the entire Earth without a scratch, and we caught it. And we followed it home. We didn't just hear the universe. We grew an entirely new sense to hear it with. And the very first thing that new sense heard was a black hole, 4 billion years and 4 billion light years away, roaring into the dark. Number 3. The burst from inside our galaxy. For 13 years, fast radio bursts were the ghost story of astronomy. Blinding flashes of radio energy, lasting 1,000th of a second, releasing in that instant as much energy as the sun puts out in days. They came from distant galaxies, billions of light years away. They were everywhere, and they were unexplained, and because we could never pin one to a source, the theories ran wild. Some serious, some not. And yes, some people said the word aliens, because when you can't explain a signal, someone always does. And then, on April 28th, 2020, one of them went off in our own backyard. 2 instruments caught it at almost the same instant. CHIME, a strange, motionless telescope in Canada shaped like a set of half-pipes. And STARE 2, an array watching the sky from the American Southwest. Both of them recorded a blast of radio energy so bright it briefly rivaled the distant fast radio bursts. But this one was different in the one way that mattered more than any other. We knew exactly where it came from. It came from a magnetar, an object called SGR 1935. And a magnetar is already one of the most terrifying things nature makes. It's a neutron star, the collapsed core of a dead massive star, but with a magnetic field cranked up to an almost unspeakable degree. This one has a magnetic field around 200 trillion Gauss. To put that in perspective, if a magnetar like this passed by at the distance of the moon, its magnetic field would scramble every credit card and wipe every hard drive on Earth. It would gently pull the iron out of your blood. These are not friendly objects, and this one lives about 26,000 light-years away, inside our Milky Way, wrapped in the shredded remains of the supernova that made it. On that night, it spun, its field convulsed, and it fired off a burst that looked, for the first time, like the cosmic fast radio bursts we'd been chasing for over a decade. CHIME saw 2 little sub-bursts a few milliseconds apart. STARE 2 saw a single sharp spike. And in that moment, the 13-year mystery cracked open. The ghost had a face. At least some of these signals, the ones that had haunted us and tempted us into wild theories, were being made by dying stars with impossible magnets. But here's the twist, and it's a good one. This galactic burst, as bright as it was still far weaker than the monsters we see in distant galaxies. Orders of magnitude weaker. So the magnetar solved part of the puzzle and deepened the rest. It proved magnetars can make these bursts. It did not prove they make all of them. Somewhere out there, something may still be producing flashes far more powerful than even a 200 trillion Gauss magnet should allow. And I'll be honest about why I find this one moving, rather than just cool. For years, people looked at those bursts and hoped, quietly, that maybe it was someone. And the answer that came back was, no. It was a corpse. A dead star, alone in the dark, convulsing under the weight of its own magnetism, screaming once into the void. Somehow, that's heavier than aliens. The universe isn't sending us messages. It's just grieving very loudly, and we happen to be listening. Number 2, the super civilization. In 1965, the Soviet Union announced to the world that it had found an alien super civilization, and for a brief, electric moment, everybody believed them. To understand how it happened, you have to meet a young astronomer named Nikolai Kardashev. This is a serious scientist. This is the man who would go on to invent the Kardashev scale, the framework we still use today to rank civilizations by how much energy they can command. A Type 1 harnesses the power of a planet. A Type 2, an entire star. A Type 3, a whole galaxy. That idea came from this man's mind. And in the early 1960s, Kardashev became fascinated by a particular radio source in the sky, one cataloged by Caltech as CTA-102. In 1963, he floated a bold proposal. What if CTA-102 wasn't natural? What if its radio emission was the signature of a Type 2 or Type 3 civilization, a species so advanced it was broadcasting across the galaxy? It was speculation, but it was serious speculation from a serious mind, and it planted a seed. Then, in 1965, his colleague, Gennady Sholomitsky, pointed a telescope at CTA-102 and found something that made the seed bloom. The source was varying. Its radio output was changing by around 30% over a timescale of just a few months. A cosmic object that big shouldn't flicker on a human timescale, but a transmitter might, a beacon might, and that was enough. The Soviet news agency, TASS, put out an announcement. Sholomitsky, following up Kardashev's idea, had found CTA 102 to be the beacon of a super civilization. And the story went off like a bomb. This was the height of the Cold War, the age of Sputnik and the space race, a moment when the impossible kept becoming real every few months. A press sensation swept around the planet, not a rumor on the fringe. A formal announcement from a superpower that we were not alone. And then the 200-inch Hale telescope in California turned its enormous eye on the source, and the super civilization dissolved into physics. CTA 102 was a quasar, one of the brightest, most violent objects in the universe, a supermassive black hole at the center of a distant galaxy, devouring matter and blasting out radiation as it feeds. Quasars, we now understand, are naturally variable. That 30% flicker that had electrified the world wasn't a message. It was just a black hole, eating. But I don't think this story is a joke, and I don't think the scientists were fools. Look at what came out of it. The embarrassment, the reach, the sheer audacity of the idea forced Kardashev to think rigorously about what an advanced civilization would actually look like from a distance, how it would shape energy on a cosmic scale. And out of that thinking came the Kardashev scale, a tool we still use, 60 years later, every single time we imagine what's out there. The false alarm became the framework. The mistake became the measuring stick. For a few months in 1965, a species that had only just learned to leave its own planet let itself believe it had heard a voice from a civilization far greater than its own. They were wrong. But you can't tell me that the wanting, the reaching, wasn't real. And it's still real. It's the reason we keep building the telescopes at all. Number 1. Little Green Men. In the summer of 1967, a 24-year-old graduate student in Cambridge, England, found a signal so perfect that, for a few weeks, some of the sharpest minds in astronomy quietly wondered if they had just intercepted another civilization. And the way that story ends is the most important idea in this entire video. Her name was Jocelyn Bell. She was helping run a new radio telescope, a sprawling field of cables and posts she had helped physically build, designed to study the flickering of distant radio sources. The data came out on long rolls of paper, printed by a chart recorder, hundreds of feet of squiggly ink lines that she had to analyze by eye. And in August of 1967, she noticed something she later described as a bit of scruff, a small strange smudge in the data that didn't fit. She could have ignored it. Almost anyone would have, but she remembered having seen it before, in the same patch of sky, and something about that nagged at her. So she looked closer. She got the recorder to run faster, to stretch the signal out. And when it finally resolved, what she saw stopped her cold. It was a series of pulses, radio bursts, coming in with astonishing, metronomic regularity. One every 1.33 seconds. Tick, 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 as precise as a clock. Now, put yourself in that room in 1967. Nothing in nature, as far as anyone knew, produced a signal that clean, that regular, that mechanical. Regularity like that meant a machine. It meant intent. Half seriously, half nervously, the team gave the source a name that tells you exactly what was going through their minds. LGM-1. Little Green Men, number 1. Because the honest truth is, they had to consider it. This might be a beacon. This might be someone. And then Jocelyn Bell did the single most important thing anyone does in this whole story. She kept looking, and a little while later, in a completely different part of the sky, she found a second one. Another perfect metronomic pulse, ticking away from somewhere else entirely. And that, strangely, is what killed the aliens. Because think about what two of them means. One perfect signal from one spot you might dream about, but two identical beacons from opposite corners of the sky, run by two separate civilizations that had somehow independently decided to broadcast the exact same way? That was absurd. Two was too many. Two meant this wasn't intelligence. This was nature. This was a phenomenon, common enough to appear in more than one place, and we simply hadn't met it yet. They had discovered the pulsar, a rapidly spinning neutron star sweeping a beam of radio energy across space like a lighthouse, and every time it swept past Earth, tick. The regularity that had screamed artificial was just rotation. One of the most profound discoveries in the history of astronomy. Anthony Hewish, who led the project, would win the Nobel Prize for it in 1974, a prize that, controversially, did not include Bell herself. But here is why this belongs at number 1. Here is the idea I want to leave you sitting with. The single most artificial-looking signal humanity has ever detected, the one perfect enough to make experts write the words "little green men" on their data, was a natural object the whole time. Nature counterfeited intelligence so convincingly that our best scientists had to seriously entertain aliens before physics talked them down. So think about what that does to the search. Every strange pulse, every drifting tone, every burst we've talked about tonight sits in the shadow of that lesson. We now know the universe is fully capable of faking a message. It makes signals so clean, so regular, so intentional looking that our instinct is to assume someone sent them. And that means if a real one ever does come in, if there is ever a genuine voice in the noise, we will have every reason in the world to talk ourselves out of it. To say, it's probably just a pulsar. It's probably just a magnetar. It's probably just the microwave. We spent this whole video listening to the sky get our hopes up and let us down, over and over. And the deepest problem isn't that the universe is silent. It's that the universe is noisy in exactly the way a message would be. Somewhere in all that beautiful, deceptive noise, the real signal might already have arrived. And the hardest thing we will ever have to do is be sure enough to believe it. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.